Welcome to Finance 201, Chapter 4 on time value of money. This is the first of two chapters we'll spend on this, and probably one of the most important concepts you'll learn out of the entire class that will apply to just about any field you go into. You'll need a financial calculator if you don't have one yet. I use the Texas Instruments BA2 Plus. You can find for about $30 new, and even less than that if you bought a used one. There are a couple of other ones, the Hewlett-Packard 12C, I believe, and the Texas Instruments TI-83 Plus with the finance app or function built into it as well. In your textbook will explain, and in this PowerPoint there's a slide to explain how to use those. But overall, the time value of money, the concept of what we're dealing with is what impact does time have on the value of money? And the overall idea is that the faster you receive some money, the more it's worth to you. So in the investment world, like for example with me, when I like real estate investing, and so when I look at something, the faster it produces cash flows, and the higher the cash flows are up front, the more the investment's going to be worth, and the more I should pay for it. And particularly with real estate. Now, why is the money worth more now than in the future? Because one concept is just inflation. It eats away your purchasing power of money you receive later. The other idea is because of opportunity cost. Now, it's worth more now because I'm able to do other things with that money versus receiving it in the future. If I receive it now, I can pay off debts, I can invest it somewhere else, I can give if I want to. And if it's in the future that's uncertain as to when I'll be able to do those other things that I'd like to do with the money. You know, if you loan a friend $10,000 at no interest, and the market jumps up 20% this year, you could have made $2,000 this year in capital gains in the stock market. But if you loan that money out, that's your opportunity cost. It costs you $2,000 basically to loan that out to a friend at no interest. Now, that doesn't mean you shouldn't do that, but that's the idea of opportunity cost. So in Jerry Maguire, when Cuba Gooding Jr. says, "Show me the money," and he wants money now, he's saying he knows that it's worth more to have that money now than waiting. The more days that he waits for a contract, the less and less that money is worth. So, for example, we'll be able to answer whether he should take a $2 million contract now or $2.5 million in 2 years. And we'll see at the end of the presentation. Now, why is it important? Because it's vitally important, because every employer you ever work for, I don't care who it is, you will always use this in every single business decision. It will affect every business decision. So that's how important it is. And if you're an entrepreneur and you start your own business, it will affect everything from the idea of even looking at whether you should buy the business or start it or not from when you sell it. So it's one of the most important concepts in the whole subject of finance. For example, you'll see there the restaurant for sale sign. You'd have to know how much in cash flows that restaurant is expected to produce and what else you could have invested the money you would have spent on buying the restaurant in order to come up with a price today, what you should pay for that restaurant. Okay, if it's cost more than what the present value of all the money that it's going to produce, you shouldn't buy it. So it helps you make decisions on whether you should even buy something or not. If Steve Jobs, when he looked at releasing the iPad or iPad 2, he had to know whether that product would overcome its cost, and had to use time value of money concepts to be able to make that decision. The same with the Carson-Newman MBA program. That program, it has to produce more cash flow and really more than something else would have at the same risk level in order for them to do the MBA program, or at least they should have done that type of analysis. I hope so. Okay, so just about every field affected by time value of money. The things we need to know to be able to calculate the impact of time value are the size of the cash flows, what the amounts are, the timing of the cash flows, and the rate of return of the cash flows. And that's sometimes called different things. You can look those up in your book to get a little more understanding on those. But basically the interest rate or the cost and investment rate. it always helps to start out any problem, time value money problem, by drawing a timeline, and that is a almost vitally important thing to do to be able to solve the problem as well. Is to look at when did the cash flows occur, what rate, and when the timing is. So draw it out like the one at the bottom of the screen slide there. The important thing is to make sure you put negatives and positives in the right place. Think of a negative cash flow as anytime money goes out from you. You've invested money or you've paid something. Anytime cash would leave you, you would have a negative sign. Anytime it comes back to you, you have a positive sign. That's positive cash flow. And that'll help you when you do later calculations as well. The first calculation is called a single period future value. And that's just looking at, if I had something today, like this $100, and I could earn 5% a year, how much would I have after a year, after 2 years? How much would I have in the future? So it's calculating some future amount based on a lump sum initial investment. Using the calculator, it's a whole lot easier. This is the calculator I use. There are also instructions after this slide. You can go back through this in your own time less quickly to be able to look through these calculations. But one thing I need to add here is look at on the second row there, it has a second, and on the third row above FV it has clear TVM. Make sure before you start any problem you clear out, if you're using this calculator in particular, you hit second and the FV button to clear the time value of money to make sure there's nothing in the calculator already. Okay, and then just make sure you get your positives and negatives right to get that value there. And this next couple of slides explains how to use the other calculators. And the idea of compounding values was originally one person who was instrumental in that was Albert Einstein, and he said the most powerful force in the universe is compound interest. Just how much compound interest over time builds wealth, at least through savings, and that's why we'll see some examples of that. For example, here if we look at this $100 initial investment, it wasn't much after just 1 or 2 years, but if we solve for 20 years at 5%, it'd be worth $265. What happens we bring that up to 40 years that we save that one initial $100, then it's worth $704. Okay, and the concept is that it's not linear, but it's exponential. Okay, the longer you have it invested, it grows exponentially. That's the impact of compounding. Present value is just going the opposite direction. Present value is a little bit more difficult for students to understand, but it's the idea that it answers the question, what would I have to invest or save today in order to end up with an amount in the future? Or what would something have to be valued today in order to produce the cash flows or a certain future amount? For example, if I wanted to save up $5,000 to buy a car, or $1,000, in this example, a little error there, but anyway, let's use $1,000 to buy a really cheap car in the future. How much would I have to invest today to be able to do that at 4% interest? Okay, and at 4% interest, the answer is $822. But that's called the present value. It's what I would need today in order to produce some future cash flow. Okay, and your book will help you with that too. And there's a few calculations here. We just switch around the formula that we use for future value in order to solve for present value. So the same formula, just for present value instead. The calculator solution. And also, there's a couple other concepts here in the book we won't hit on a whole lot. One is computing interest rates. You can solve for any one of those variables in the calculation, and you can do that using the calculator most easily. We can solve for interest rate, so we can ask the question, what rate would I need to say if I have $800 today and I want to save $1,000, I need to have $1,000 5 years from now? What rate would I need to earn on my money to get that? Well, that's a good question. We have to ask that question a lot. Or we need to solve for rate of return. In investing, we solve for rate of return all the time. We can also solve for time, how long it would take us to reach a certain amount of money based on what we have to save today. There's other examples of that calculation. And the last concept is called the Rule of 72. That's really interesting, just an easy way to see how long it would take money to double. And the big idea of it is you take a percentage return, like in this example, 6%. We can invest something at 6%, a 6% rate of return. If we divide that into 72, we can know how many years approximately that it takes our money to double. Okay, so if we invested $100 using this formula, we can know that in 12 years we should have $200. And Einstein known to come up with this rule. And it works really neat, just a quick and easy way. And the rest of this presentation shows how to calculate that. And our solutions should have Cuban good engineer should have taken the $2 million or $2.5 million. He should have taken, if he could have saved, we had to know a rate to be able to solve the calculation. But if he could have invested his money at 12% somewhere else, like for example in an athletic shoe business for the next 2 years, okay, he should have taken the $2 million because the future value of $2 million at 12% interest, invested at 12% for 2 years. After 2 years, he would have $2,508,800, a little more than he would have by waiting and getting a contract that's a little bit more money, $2.5 million in 2 years. So he should have taken the $2.5 million now.